Hello students, welcome again our chapter 6 AOD. Students, today I am going to new topic, increasing and decreasing functions in their domain interval values. So in the last topic I explained you one of the 5 topics, strictly increasing and strictly decreasing and constant function if a derivative is 0. But here students, one more theorem available in your textbook level. It's very easy. So first of all, you write down these 3 points. Let f be a continuous on close bracket a comma b and differentiable on open bracket a comma b. Then f is strictly increasing if your derivative is f dash x greater than 0. In that domain x belongs to a comma b. And if your derivative f dash x less than 0, then x belongs to a comma b, it is strictly decreasing. And third, you know constant function, derivative first order is 0 in the domain x belongs to a comma b. So there are strictly increasing, strictly decreasing, and here constant. Now students, I start today first numerical exercise 6.2. Show that given function 3x plus 7b is strictly increasing. It means we will prove first derivative greater than 0 in their domain. So students, I just operate here derivative for these functions. Differentiation with respect to x. So f dash x students, very easy. Dx of 3x plus 17. Here 3 x plus 0. And is always greater than 0 in their domain. Condition right? If x belongs to R, what is your f dash x? Greater than 0. It means you prove it is strictly increasing in their domain. What is domain? R. R means minus infinity to plus infinity, whole number line. Therefore, f is just I telling that strictly increasing in minus infinity to infinity plus, either you can say it is R. So R also true, minus infinity to infinity also true, and here students, it is your known first power, one power, it is line. Line is also increasing in both way, and that's your proving here students easily done. Now students, coming to second question is also same as very easy. Prove that fx is e raised to 2x is strictly increasing on R. Generally students, every exponential function is a increasing function. Anyway you put it, sure graph is going upward sides. It means increasing sides. We prove here derivative wise. Just apply differentiation with respect to x. So students, you getting here only dx of e raised to 2x. Now apply derivative e raised to 2x into 2. But you know that for any x belongs to R, every exponential function is what? Never 0, never negative, always positive. And integer, both sides, nothing change. It is f dash x greater than 0. So that's why I showed in here f dash x greater than 0. It means our proving is done. So on x belongs to R, fx is strictly increasing in R function. So students, here this question is very easily done here. Now after that I am going ahead third one. Now students, question number 3, that is the IIP questions. Show that given function fx equal to sin x is strictly increasing in 0 to pi by 2, strictly decreasing in pi by 2 to pi, and third, neither increase nor decrease in 0 to pi. So generally you know that it is your 0 to pi means Students, you have to only two quadrants. One of the 0 to 90 there and 90 to pi. It is all S, T, C wise. First quadrant, all second quadrant sine for and cosine for positive. I start just my function sine x. Differentiation with respect to x. Just to students take it down that you know that sine x derivative is how much? Which is cos x. And I start one by one. First case. Students, I operate now this first one. Just like A here. So I write down also A. Strictly increasing to in 0 to 90. So in x belongs to 0 to 90. You know that. What is your answer? Cos x. In first quadrant. So here write down greater than 0. So f dash x is greater than 0. So f is strictly. Students, strictly because greater than 0. If you prove greater than or equal to 0, that strictly word is not needed. Only write down increasing. So f is strictly increasing on 0 to pi by 2. Here first is the now second to pi by 2 to pi. So the same way here in x belongs to pi by 2 to pi. Which quadrant? Yes, pi by 2 to pi. Second quadrant. In second quadrant cos function negative. So less than 0. It means here f dash x less than 0. Therefore, f is strictly decreasing. Or decreasing on which interval? Pi by 2 to pi. Now time coming to third. Third, generally in exam asking third one. Mostly question is given, show that the function fx is sin x, prove that in neither increasing nor decreasing in 0 to pi. So students, you must be prove 0 to pi by 2 strictly increase, pi by 2 to pi strictly decrease, compulsory, and here they increase, here they decrease. That's why in 0 to pi, in whole interval, then neither decrease nor increase. So at the last, you just write down this statement. In 0 to pi by 2, f is strictly increasing, and in pi by 2 to pi, f is strictly decreasing. That's why actually statement 1 and statement 2 is the answer of statement 3. Okay, but first you prove that, and last write therefore in 0 to pi f is this statement right now, neither increase nor decreasing. Here students, your this questions is happily done, but these are IMP questions. You tick mark in the IMP list. Mostly exam asking this statement only, not given for second, but you necessarily needed to prove first and second, then after last. Here students, our third question is done. Now students, question number 4. Given functions 2x square minus 3x, we determine in which intervals they are strictly increasing or strictly decreasing. My students, I just derived derivative for these functions. So, given fx, we have to 2x square minus 3x. I just taking derivative f dash x dx of 2x square minus 3x. You know that 4x minus 3. And now students, here I just plot one of the line minus infinity to plus infinity. Here you getting 1 point. But that point is must be you taking that f 4x minus 3 is equal to 0. So here write down some note. We take there are two cases. One of the x greater than 3 by 4 and x less than 3 by 4. It means this one of this domain and that is the second domain and two interval coming. So students, here I start one of the domain and I start the solutions. One of the x less than 3 by 4. Here interval, my interval is first this one, minus infinity to 3 by 4. Same as second. This is a second. X more than 3 by 4. Interval is a 3 by 4 to plus infinity. And now time check to value x less than 3 by 4. So 4x less than 3. So 4x minus 3 less than 0. And that is your f dash x. It means my f dash x value 4x minus 3, here negative coming. And now this negative coming. That's why students, what you write down? Strictly decreasing. Yes, it is strictly decreasing function. And here, second condition, x more than 3 by 4. So 4x more than 3, 4x minus 3 greater than 0. Table necessary write down in example, so students, it's the compulsory. So here your f dash x what? Positive. So my answer is strictly increasing. That's your answer. Over and so second one. So at the last, my answer is in interval. Students, in the interval. My first interval is a minus infinity to 3 by 4. Is that strictly decreasing? Yes. Strictly decreasing. Downside arrow taking. And in interval, what the interval? 3 by 4 to plus infinity. It is a strictly increasing. And here your answer upwards. Second one upwards and first one downwards. Here students, your question 4 is happily done. Now students, we are going ahead fifth one. Here also asking what is the interval in the increasing and decreasing. So same apply, derivative, differentiation with respect to x students. So d dx you just derive first of all 2x cube, 3x square, 36x plus 7. You getting just your first order derivative. 3 2s are 6x square, 6x minus 36 and 7 square. 3 2s are 6x square, 3 2s are 6x and 36. Students, here common checking x. The x square minus x, 6 is 36. There are two answers. 6 ones are, I want 1. So minus 3 plus 2. And here you checking one by one your intervals. This never 0. Here minus 3 and plus 2. But this equal to 0 taking their answer is 3. This equal to 0 taking their answer is minus 2. And there are 3 intervals coming. X more than 3, minus 2 to 3, and x less than minus 2. And one by one, I start my solutions by the domains. Students, in the domain, here, your first domain, here I start. X less than minus 2. Definitely, you can say interval. My first interval minus infinity to minus 2 in this way. Correct? And second same minus 2 to 3. Interval also same minus 2 to 3. And that's your second case. And third, x more than 3. Students, x more than 3, third interval coming here. It is 3 to plus infinity. Now I go to finalize this 3. Students, here condition wise what I explained, shortcut apply, because there are three cases. One of the 6 definitely positive, positive, positive. Correct? Now x minus 3. Then after x plus 2. And here final I derive my adversarials. It is that 6 into x minus 3 into x plus 2. Students, here you think about, here minus 2 to below numbers. Any one number is thinking but below the minus 2. Just like minus 3. Apply your minus 3. You gauge it, minus 3 and minus 3, minus 6. It means negative. Same apply minus 3 plus 2. Again minus 2. It means negative. So finally, what's your answer? Positive, negative, negative, multiplied. It is purely positive. Yes, students, here your answer is strictly increasing in this data. Now I think about here. Minus 2 to 3. Any one number you decided. Either minus 1, 0, 1, 2, 0.1, 0.2, 0.5, any. I decided 0. And apply here 0 minus 3 negative, 0 plus 2 positive, and choose a multiplied. So positive, negative, positive. All multiplied and is negative. So my answer is here, students. It is strictly what? Decreasing. And that's your answer. In third case, more than 3. You checking any numbers more than 3, just like a 4. Apply here. 4 minus 3, 1. Positive. 4 plus 2, any. Positive. And my answer is a positive. So I just write down it is strictly increasing interval. So in final my answer in interval. Which interval? The increase, decrease. Students, here this increase, this are increase. First and third. So here I write down minus infinity to minus 2 and 3 to plus infinity. Correct now? Increasing and increasing. Yes. Here strictly increasing. And in interval, which interval decreasing? Minus 2 to 3. Strictly decreasing. Yes. It is strictly decreasing. And here, students, your 3 marks question done here. Happily. First I say derivative, and these 2 points related respectively taking 0. You are getting here line or number line. And after that decided domain, interval, and values. This never necessary to write down in exam. It is necessary plus minus solutions and easily fixed. Now students, question coming to sixth one. In this sixth one, total there are 5 numericals and question same asking in which interval they are strictly increasing and in which interval it is they are strictly decreasing. First one very easy. Fx is equal to x square plus 2x minus 5. And students, I apply first derivative. Yes. F does x d dx of my question there x square plus 2x minus 5. So there are 2x, 2 and 5 derivative 0. 2 common check. And after the students, you know, just you got one of the number line it belongs to R. And here you check if you 0, what you get? Minus 1. So one answer is greater than minus 1 and less than minus 1. 2 values defined by domain. So my first answer to start in the domain, interval, and after the solution. First domain is x less than minus 1, interval ready. Similarly, second domain x more than minus 1, interval also ready, minus 1 to plus infinity. Here students, number assume either condition. I say condition for your best understanding. To multiply. Yes, it is your plus x. What is your plus x? 2 into x plus 1. And the number is coming what? Yes. 2 into x plus 1 is less than 0. Yes, I will direct suggest minus 1 below number assume minus 2. Multiply it. It is answer is negative. So, it is strictly decreasing. And that's your student's answer to first. Same here condition, if you x more than minus 1, x plus 1 more than 0, 2 multiplying more than 0. So my answer is positive. It is strictly increasing. And that students, your answer is over here. After that you write down last answer. So my answer is in interval. Which interval? Minus infinity to minus 1 is strictly, first answer is strictly decreasing. Downwards arrow you take that. And in interval, the second answer is minus 1 to plus infinity is strictly increasing. That's your students. Happily, your question number 6, first one done here. Now students, I am going to second one. Fx given 10 minus 6x minus 2x squared. Same apply. Directly taking f plus x, which have to d dx of 10 minus 6x minus 2x squared. Apply that. 0 minus 6 minus 2 to the 4x. Students, minus 2 you common taking. You have to remaining 3 plus 2x. Correct? No? 3 to the 6, 2 to the 4. And here your first derivative over. But I go through the normal line. Plus infinity to minus infinity. This number taking respectively 0. So 3 plus 2x 0. What is x? Yes, x is minus 3 by 2. Yes. And these are first case. More than minus 3 by 2. And here less than minus 3 by 2. And after all, I am going to now my domain values. It's very easy and simple calculations. So, I am going to my table domain. So that's your first domain is declare x less than minus 3 by 2. After the interval, your interval is a minus infinity to minus 3 by 2. And then after you within minus 2 and 3 plus 2x, it's very simple. X less than minus 3 by 2. So 2x less than minus 3. So 3 plus 2x is less than 0. 3 plus 2x, this one. Now multiply by 2. 3 plus 2x less than into 2, so 0 into 2. And if you minus multiply, they getting greater than 0. And here students, you are over at plus x. Minus 2 with the 3 plus 2x is table over. And your first case is over. Either you take any number wise, and number wise is also you judge. This answer is what? Positive. So my answer is strictly increasing. Now second. The second interval, x more than minus 3 by 2. It means minus 3 by 2 to plus infinity. Condition also same. X more than minus 3 by 2. 2x more than minus 3. 3 plus 2x more than 0. So multiply. And if you minus multiply now, less than 0. This here, next answer is ready because it is your f(x). Less than 0, negative. So my answer is what, students? Strictly decreasing. And that's your final answer done. Out of that you write down the interval. The first interval, this one, minus infinity to minus 3 by 2. It is strictly increasing, yes. And one of the in interval, the second interval is this minus 3 by 2 to plus infinity. It is strictly what? Decreasing. And here students, our second question is also happily done. Sometimes in exam also you don't write the conditions, don't worry, it is true, plus minus 1 is right, but here I explain deeply how they convert to positivity and negativity. Okay? Now students, next question, third one. It is the most oriented, exam oriented, because already 3. Okay, same apply derivative. Your derivative after x dx of minus 2x cube 9x square minus 12x plus 1. So students, it's very easy. Minus 6x square, 9 2s are 18, minus 12. And here you taking the common. Students, minus 6 I common taking sin square, 6 3s are 18, and 6 2s are. It's very easy. It's more splitting. 2 1s are 2, x plus 2, and x plus 1 here. So students, I just got on the number line plus infinity to minus infinity, and we are taking the 2 points. Minus 6 never 0, but this equal to 0, then minus 2, and x plus 1 equal to 0, then minus 1. So your answer is minus 2 here, minus 1 is here. Always take left side lowest number. So your first domain, second domain, and third domain, this one below the minus 2. Yes, minus 2 to below. Here minus 1 to more than. And these are interval minus 2 to minus 1. Now I start students. Find my table. So first of all value domain. After that interval. And all value I just one by one decided. So my domain parts. You properly draw the table. First domain x less than minus 2. Interval ready. Same is now second. Second is a minus 2 to minus 1. Interval ready. And third case is this one. X more than minus 1. Which have to minus 1 to plus infinity. Now students, I just taking first minus 6. Minus 6 in every time it's negative, negative, negative value. Correct now? Yes. Here my table is ready. Now I taking the x plus 2 and x plus 1. So here x plus 2 value related. Here x plus 1 value related decision. And here your f dash x. Minus 6 with x plus 2, x plus 1. And start the students your confirmations. Here I take direct. Just you assume that minus 2 to below number. It is minus 3. Apply here. Minus 3 plus 2. Negative numbers. Here minus 3 plus 1. Again negative number. And chosen multiply. Negative, negative, negative. Which is negative. So here strictly decreasing your answer. Correct? Now here just minus 2 to minus 1. Any number. But between that, minus 1.5 I taking. Here minus 1.5 plus 2. It is positive. Here negative. Here apply then. And overall multiply. Minus plus minus. It is false. So my answer is strictly increasing. Here you are. Second answer. And now third, more than minus 1 students assume. More than minus 1 means either 0, 1, 2, 3. I take 0 and apply here. It is positive. Here positive. Total multiply. It is negative. So my answer is strictly what? Decreasing. That's your decreasing function. So my answer is in the interval In the interval, I first write down decreasing in first and third. First and third. Minus infinity to minus 2 and minus 1 to plus infinity. Minus 2 to minus 1 and minus 1 to plus infinity. There are strictly decreasing function. And next one, in interval. That's our strictly increasing, students. Minus 2 to minus 1. It is strictly increasing. And that's your students here. Next, our this increasing and this two are decreasing. Depending on this drawing, here students done. And this question is also, students, third question I completed here. And students, here I stop this part. Further explanations for this part, this exercise, I explain in the next part. Okay? Bye bye. See you.